Hello, everyone, and welcome to today's webinar presentation, Top 5 Situations Where Mobile App Security is Paramount, brought to you by Guardsquare. I would like to introduce you to our presenter. Our presenter today is Ryan Lloyd, Chief Product Officer at Guardsquare. Ryan, take it away.
Great, thank you so much. Very excited to present here today. The topic we want to talk about is diving deep into mobile application security and really illustrating it through some real examples, industry examples of some of the security concerns that mobile app developers will have. Super important topic for me because mobile apps are everywhere in our world today. It's how we order food, get transportation, book flights, play games and consume entertainment, healthcare, banking. It's all around us. And the last 2 years has even accelerated that more than usual. So glad to be here and to hopefully shine a light on some of the security considerations you have as an app developer building mobile applications. So maybe we can start with some of the myths that are out there on mobile application security, because when I talk to customers and prospective customers, there's things that we hear over and over again that I'd like to address. The first myth or concern that we hear a lot about is that the mobile operating systems, Android or iOS, they provide adequate protections, that Google and Apple really care about security and therefore we don't have to worry about it as app developers. And it's true that Google and Apple as the big ecosystems for mobile apps do care about security. But the angle that they're concerned about is quite different than the angle that an app developer is concerned about. So Apple is a great example. Apple cares very much about privacy and the security and safety of the end user who uses their phones and their devices. But Apple isn't so concerned necessarily about an app developer who builds a game and whether people are cheating in that game. That responsibility really does fall to the app developer themselves. So the point here is that while the ecosystem might be secure, there are still attack vectors and threats that exist that an app developer is uniquely positioned to need to address and consider. The second myth that we often hear is that, well, sure, Android apps are targets for reverse engineering and attacks, but iOS isn't. And that's just not true. We've done a lot of research on this, and there are certainly aspects of reverse engineering an iOS app that are more complicated. It's technically a harder activity, requires a lot more specialized knowledge. But if you have that specialized knowledge, it's still quite straightforward, and there's lots of tooling out there to help with decompiling, identifying symbols, and dynamically instrumenting and attacking those applications. So it may not be as widely understood, but if someone's really interested, the bar isn't really that much higher for iOS. Another thing we hear is that, well, the backend server contains all the important aspects of my application. So that's the primary thing that we concern about. The mobile app is just a front end that we don't need to concern ourselves with. And I think as we go through some of the use cases and examples here today, we'll see that that's just not true. There are actually legitimate reasons for reverse engineering and attacking the mobile app itself, that it is an attack vector. It's a unique one. And then lastly, some folks think that mobile app security is really only a concern for regulated industries, finance specifically. And I'd say finance was certainly the first early adopter of the mobile app security practices, but we'll go through examples across different industries today that illustrates that this affects a lot of different industries in ways that you may be surprised to find out. So some other sort of data points from our research, and for us, when we think about mobile app security as a provider in this space, we think about it as how do we help your brand ensure trust and loyalty in how they interact with your brand. There's a lot of different aspects here. First of all, ad transactions lot of ad transactions are fraudulent in the mobile app space. People that reverse engineer and modify applications to bypass ads or to redirect ads to their own ad services to generate monetization. We also see a lot of apps in the App Store that we've tested using some of our security analysis tools still don't pass some of the really basic security tests. We still see a lot of advancement in malware and attacks on financial services applications and even modern payment services applications. And still a growing number of fake applications that are out there in the marketplace that people are being convinced to download because they have maybe free premium features that are released either in the App Store or oftentimes in secondary app stores that users are encouraged to sideload from. And we're seeing these issues across both Android and across iOS. So before we kind of dive deep into the industry examples, these 5 sort of real world examples of where this occurs, I thought it would be helpful to talk a little bit about how to think about mobile app security. And the good news is OWASP as an organization, a foundation really, has put a lot of research into projects to educate people on both the mobile top 10, which are the 10 sort of categories of mobile security issues that people need to be most concerned about, as well as providing guidance on how to assess and how to test your mobile app to ensure it's secure. So OWASP is a great resource, a lot of great projects. Guardsquare is a corporate sponsor of the mobile projects that they have going on. And it covers everything. Like this mobile top 10 is a really good starting point for you to understand the different aspects of security for your mobile app. You know, number 1 on the list is improper platform usage. So using the Android or iOS security controls, permissions, or intents in an incorrect way is a big issue. Storing data locally on a device in an insecure way is another key security issue that mobile app developers face when they store sensitive data in the wrong places in an unsecure way. Communication, this one's getting better, I would say. You know, not communicating in clear text. You know, everyone kind of basically understands the premise of using TLS and SSL and SSL pinning, but there's still a lot of details within that category that are often overlooked by developers. Insecure authentication and authorization are key areas of concern for developers, making sure you minimize the privileges a user needs. They're authenticating at the right moments whenever any critical function is being performed. Insufficient cryptography, making sure you're using the right modern and current crypto throughout your app when you're encrypting data or storing data. We see a lot of folks relying on legacy crypto, for example, in their applications. General code quality, which is pretty well understood. And then the 8th and 9th item here are ones that are less well understood, code tampering and reverse engineering. And we'll talk a lot about that today in the real world examples, because one of the unique aspects of mobile applications is that the people using your app are the users who could be tampering and reverse engineering your app to figure out how it works and to you know, derive some sort of gain or benefit to their advantage. And we'll talk about the use cases for that. So a lot of applications will have weaknesses in them because they haven't implemented protective measures around tampering or preventing reverse engineering of their application. So anyway, OWASP, great resource. If you go to owasp.org, check out their mobile projects. They'll give you a good overall perspective of some of the concerns in mobile app security. So let's try and make this a little bit more real with some real world examples. We've got 5 industries here that we're going to focus on with some specific examples. So the first one we have is financial services. I think as everyone is aware, financial services on mobile has become ubiquitous, whether it's personal banking, whether you're using PayPal or Venmo or tools like that to transfer money and just pay for things with friends or colleagues. A third of the internet users in the world have used mobile payments in the last month. So if anything, this is a pretty ubiquitous category of use case for mobile apps. And so there's three different scenarios that we see as the most important ones to be aware of for financial services applications. The first is compliance with regulatory standards and requirements. So we continue to see a lot of evolution of standards, whether it's PCI, whether it's the contactless payment standards or the upcoming mobile payment standards that introduce security requirements that need to be met when handling payment transactions and data. So this is probably one of the biggest industries that we focus on, and that's just because the compliance needs are there. So that's kind of the background and context of why it matters if you're in the financial services space. But then if you just take the need to demonstrate compliance aside, there's also good business reason to do so as well. One particular use case is monitoring for fraudulent activity. So what a lot of our customers will do is they'll, you've probably seen this before. If you use a credit card, you'll get fraud alerts, or there'll be fraud detection systems that these institutions have in place. And what those fraud systems do is they collect insights from different data sources that could be indicators of fraud, and they kind of risk score transactions and behaviors and whatnot. So from a mobile app security use case, there are behaviors when somebody's tampering with your application that you may want to know about. So monitoring for those, tracking them, recording them, and feeding them into a fraud system is a use case that we commonly see that exists. And then protecting APIs. So the thing about reverse engineering, a lot of people will spend time reverse engineering a mobile application to understand how it works. And one of the main reasons they want to understand how it works is they want to see where data is being sent. They want to find keys or tokens that are used to transact data so that they can simulate or spoof that data. So another sort of security use case here in the financial services scenario is protecting those APIs to try and ensure that transactions are legitimate and they come from the app that it's intended to come from. Good example is if you're a payment processor or services company, you don't want other companies to learn about your APIs and to be able to access them and process payments using your services on their application or their website without being authorized to do so. So you want to protect the legitimacy of those APIs and make sure they're only coming from the apps and the endpoints that you intended. So financial services is big, and as I said, standards and specifications are a big driver for why security is important to those companies. EMVCo is a good example of a global technical body, a consortium collectively owned by a bunch of the card processor companies that have all gotten together and have set standards for different aspects of security that are required for companies that want to process payments through their services and platforms. So financial services is the biggest, most obvious scenario where mobile app security is important. Anywhere there's money involved, it becomes quite critical, but that's not the only industry where mobile app security matters. Another one that we started to see a lot of relevance in recently is consumer technology. And there's two main concerns the companies in this space have. So first of all, a lot of the consumer tech that we see, whether it's IoT technology, your television, smart televisions, fitness equipment, streaming video delivered through mobile and different devices like that. These are all sort of innovative areas of the market where there's a lot of competition. And so I think what a lot of our customers are concerned about is two things. One, making sure that the things they're working on, the new features they're building, don't get unannounced or get announced before they're ready. And the second thing is they may have proprietary capabilities or IP or logic, and they don't want people to reverse engineer them and build a cheaper, equivalent and undercut them in the market that goes on. So unannounced features is a big issue for consumer tech companies. And, you can just look at some of the headlines of examples of this. So, companies like Microsoft, companies like Apple are the most obvious examples, but even the niche consumer tech companies, there'll be fan sites, there'll be tech media sites that are employing people to reverse engineer your app, to look at the code, find the features that haven't yet been revealed or announced, and spoil it, leak them to the market. So some examples here with Microsoft and, early indications that they were building an Android app to support for the Xbox. Apple, obviously, there's a whole ecosystem and economy around leaking what's coming next with Apple. But it goes broader than that. You can think of lots of fitness companies and streaming media companies where people are trying to look at the apps they're releasing, decompiling them, and hoping to break news about what's coming out. It just makes it difficult for competition, and also makes it difficult for them to maintain that element of surprise in their roadmap. So we've seen a lot of use cases where consumer tech companies are trying to prevent people from stealing their IP or even just leaking their roadmap and their features. So that's a consumer tech scenario. That's the second scenario I want to talk about. Third one here is around mobile gaming, which when I joined Guardsquare, I was surprised to learn just how big the mobile gaming market had become. So when you think about gaming, you think about the Xbox, the PlayStation, or PCs, but mobile accounts for 57% of the worldwide video game revenue, and that's a statistic that I think is a couple years old now, and it's growing fast. So it's a huge market. A lot of money is being spent, even backed up by the fact that Microsoft acquired Blizzard earlier in the year. So there's a lot of money going into the space of gaming and mobile gaming specifically. And so you think, okay, mobile games, why do we need to be concerned about security, about something that's meant to be just casual and fun? Well, it turns out that people like to cheat in games. And so there's actually two types of concerns here. One is cheating. So when you've got big multiplayer games, or you've got the whole concept of esports, which has taken off in the last several years, where there's real legitimate competition and money at stake, people are looking for interesting ways to cheat in these games. And largely the way people cheat in mobile games is someone out there in the community will reverse engineer, they'll decompile the legitimate game, and then they'll find how that game works, and they'll modify it in some way, maybe to gain some advantage, to prevent them from being damaged by an opponent, or to get more coins or resources that help them in the game, whatever it is. They'll figure out how the game works, they'll reverse engineer it, they'll make some modifications, then they'll repackage that game and publish it on a secondary app store. They won't publish it in a legitimate app store because Google or Apple would pull that from being published, but they'll put it on a secondary app store where someone else can download it from. And if other folks in the gaming community realize that there's a modded version out there that gives them an advantage, suddenly you've got tens of thousands of users that are flocking to that modded version, loading it on their device, and now you've got a community of people cheating in your game, which is ruining the game for everyone else. It's ruining the competition and creating churn and affecting the retention of users, which is why the game studios care and implement solutions to address that. So cheating in these big multiplayer games is a big issue. The second issue you see more in the casual game market is people modifying games to bypass the monetization, the subscription or the advertising mechanisms that are built into the game. People repackage a modified version that has no ads or unlocks premium features, or makes it so you get the full functionality of the game without having to pay for the upgrade. And again, it just erodes the revenue for the game studio that worked hard to create that game. And then similar to the financial services use case, we've seen mobile gaming companies implement the same sort of like fraud detection where once they put the right mobile app security measures in place, they can identify people who are tampering with their app, what their user IDs are, and then maybe ban them from being able to use that user account on the game. And again, maintain the integrity of the game overall. So lots of good headlines and examples of these game cheats and their existence. So you can go deep on the internet and find lots of examples of forums with very vibrant communities of folks that are cheating in games and publishing mods and whatnot. And some of them are very sophisticated. These multiplayer shooter games that have cheats that allow you to see through walls or that auto aim at your opponent. Pretty sophisticated capabilities in that regard. So that's mobile gaming, the third scenario in our presentation here. The fourth one is around healthcare. Healthcare is really interesting. Particularly in the last couple of years, we've seen a lot more increased demand for telehealth and people looking to access health data from their devices and remotely. And so whether it's connected medical devices or telehealth software, there's a lot of concern that exists in the healthcare and medical space around mobile apps and the security of those apps. I think one of the most interesting examples of concern here is something that goes back to some of the first connected medical devices that came on the market a few years ago. You had pacemakers or infusion pumps that had a mobile app and a connected medical device. And you had these security researchers that were showing up at the big security conferences like Black Hat and others presenting how you could hack into these devices. And one of the ways that they learn about these devices is through reverse engineering, decompiling the mobile app, seeing how it connects to the physical medical device, maybe creating a script or an app of their own that simulates that application so they can remotely connect to those devices, even if they're not the legitimate user. And whilst the threat of that may seem a little bit far-fetched, what is the probability of you as a user of a medical device having someone that's going to tamper with your device? It doesn't even have to get to that to be a major concern for a company that's building a healthcare and medical app, because the brand impact alone of that presentation of Black Hat is enough that it's going to get a ton of media coverage and really impact your brand, even if the threat never materialized and actually endangers anyone. So a lot of the protection mechanisms to prevent reverse engineering and tampering is just as much about protecting the brand of the organization. We also see a lot of focus on proprietary algorithms or IP that needs to be protected. Dosage of medicines or machine learning algorithms that are used, those can be proprietary and are a big part of the value of that clinical component or product. And so preventing competitors from being able to decompile that and recreate that is, there's a lot of R&D that goes into that you need to protect. And then lastly, personal health information. There's both a patient safety and a personal health data component that regulators are looking to make sure are protected. And so protecting your mobile app is as much about trying to make sure that you can demonstrate that the risks associated with reverse engineering and tampering won't impact a patient or result in the compromise of data or health information for that patient. So healthcare is a great example of another industry and scenario where mobile app security is becoming really important. Two headlines here from security researchers in the past few years, where again, at these security conferences, people are demonstrating how to put malware on a device or how to remotely control some of these devices. And again, it's not so much about the reality of that being an attack, but it's about the PR and the brand impact that comes with that. So the final use case or scenario that we'll talk about here is government and public services. This is another industry where we see a lot of governments modernizing their services and trying to deliver those through digital channels. And I would say there's parts of Asia where they're much more sophisticated in the adoption of digital services for government and public services. But that's started to really take hold in Europe and in North America now as well. And as soon as you put these government and public services onto mobile apps and make them accessible in a digital way, it raises certain concerns. You've got to question the integrity and the authenticity of public data. So you think about things like voting and digital systems that are used to tally votes or even cast votes. How do you ensure the integrity and the authenticity of that data? Or if you're collecting public health data, these COVID trackers and other different public health systems that are digitally enabled now, how do you make sure that data's got integrity to it and can be trusted? There's a privacy element. If I'm filling out my taxes, filing my taxes from a mobile device, accessing different government services, how is the data about the benefits I receive or my social security number or other aspects of sensitive data, how is that safeguarded and protected? And then lastly, security of financial transactions. So government public services is really not that much different from financial services when it comes to filing taxes, paying bills. How do you make sure that the security of those transactions are assured? So you can look at a lot of different examples of governments and public services that are expanding to have a digital footprint, whether it's mobile voting or just accessing government benefits or a lot of border agencies trying to digitize their services. Lots of examples of these services that are being made accessible through digital channels. And there's real security and privacy issues that arise once you do that. So those are kind of the 5 scenarios that we were hoping to describe today to kind of make it real about why mobile app security has reached the point where it needs to be taken seriously. Mobile devices are in all of our hands. They contain an increasing amount of sophisticated capability, and there are very consumable tools out there for reverse engineering and tampering those applications that can be used to exploit in the ways that I've described in the presentation today. So how do you defend against that? Our point of view at Guardsquare is that strong security requires defense in depth. There's no single solution or tool or answer that you can rely upon to secure your mobile applications and protect your brand and your end users of your app. You've got to think about it holistically. So we think about these 5 categories as being quite fundamental steps to take as part of a defense in depth strategy for mobile apps. The first being application security testing. So getting a baseline understanding of how secure your application is, hopefully automating that practice so that you can identify any newly introduced vulnerabilities every time you do a release or do a build of your app, because we know these mobile apps are being updated every week or every month. So we got to test for security frequently. Second aspect is code hardening. So making it difficult to decompile and understand the inner workings of your application, leveraging techniques like obfuscation and encryption throughout your application that protects it from reverse engineering. Runtime protection, which is sort of an extra layer beyond code hardening, which is there to help detect when people are doing something malicious and tampering with your application. You want to detect that and you want to prevent it. You want to crash your app if you notice that it's being run on a debugger and someone's trying to hook a sensitive function of your application. You don't want to allow those attackers to be able to tamper with and manipulate your application. You don't want to allow them to be able to re-sign a version of your application, things like that. And then pen testing. So pen testing is a good way to get external validation of the security of your application. So you've done your security testing, you've done code hardening, you've protected your app. You know, every once in a while, every quarter or once a year, you should also invest in some third-party assessments of your application to get some outside-in perspective from professionals who are going to be adversaries and really put your app through the same rigor that an attacker would. And then lastly, threat monitoring. You know, we think it's important to also implement in your application the capabilities to detect when tampering and reverse engineering is occurring and report that. In the financial services use case we described, we talked about fraud monitoring. It can be really helpful if you notice that certain types of users are consistently trying to tamper with your application. You might note that and use that to help assess the risk score of that account or the transactions that they're performing. Or in the gaming scenario, you might use those threat insights to identify users who are cheating and ban them from your game so they can't use their user ID anymore and impact the quality and competition of the game that you're providing. So that's what we think of when we think about defense in depth. So to summarize quickly, you know, mobile apps and services have reached pretty critical adoption across a lot of different industries. And if you just look at your own phone, you'll see lots of examples of use cases that we rely upon mobile apps every day. And hopefully the examples we walk through today give you some examples of you know, where there's risk and threats to a mobile app developer across those different types of applications. The security risks are well known and the attacks on mobile applications are pervasive. So it may seem like they're not in the headlines very much, but if you go deep on the internet and look up reverse engineering of mobile apps, there's plenty of blog posts and GitHub code samples and examples of people that are reverse engineering and attacking mobile applications for their benefit and gain. And different industries have unique ways in which that manifests. So reverse engineering and tampering is common across all of these apps, but why they do it and how they do it does differ quite dramatically. The reason someone tampers and reverse engineers a mobile game is very different than why they would manipulate a medical app or a consumer app or an app to buy tickets to concerts, for example. And then lastly, you know, a comprehensive mobile security strategy can help mitigate a lot of this risk. And you really need to take that defense in depth approach to adequately protect your app and your brand from the risks that exist in the mobile app ecosystem. So hopefully that gives you greater insight on the risks and some strategies and approaches to take, you know, if you're concerned about the security of your mobile application. We'd be happy to talk with you more. Feel free to reach out to myself, visit Guardsquare. you can learn a lot more about mobile application security, the risks. Otherwise, thanks so much for joining the presentation today.
And with that, DZone would like to thank Ryan for an outstanding presentation. DZone would also like to thank Guardsquare for providing our audience with a great webinar. Lastly, thank you to everyone who attended today. We hope you learned something new that will help you in your developer career.